Good morning, children. So, in the last class, we started our concept by introducing to the light. Then we learned the properties of a light. Then we learned a bit about a spherical mirrors. Then I also showed you a spoon. So, today's class, we are going to start with a game. Okay. So, now I want everyone to consider a spoon. Okay. So, take a spoon and we have two surfaces on a spoon. One is bent inwards, the other one is bent outwards. So we are familiar that these are the curved surfaces, not the plain, curved surfaces. One side it is curved inside, the other side it is curved outside. Now I want all of you to just take a spoon and observe yourself in the surface where it is curved inside. So when you observe yourself in the surface where it is curved inside, you can see your image is inverted. Okay, you are looking ulta. Okay, so and when you just take a spoon away from you and when you just take a spoon in front of you towards you, so the image looks funny. So whatever you are seeing yourself here, it looks funny. Now consider the surface which is curved outside, then which is curved outside, then observe yourself. So whatever image you are seeing right now in the spoon, it is different from the surface what you saw with the curvature inside. Okay, so by this we can predict there will be change in the properties of light through the spherical mirrors. Okay, so spherical mirrors means a curved surfaces. Mirrors which have a curved surfaces are called as spherical mirrors. Don't forget to play this game, that is taking a spoon and observing yourself using the surface inwards, using the surface outwards. Okay, now when I consider this curved surface, okay, curved surface, let us take an imaginary circle over here. Okay, the curved surface is a part of this circle. For example, let me clear you. See, this is a curved surface which I took, curved surface. Okay. Then, when I draw an imaginary line over here, when I continue that curved surface, I will get a roughly a circle. Okay, roughly a circle. So, I can say that this curved surface is nothing but it is a part of a circle or a sphere. The spherical surface what we got, it is a part of a sphere. So part of a sphere means it should be having the center, okay, center of a circle. So this part, let us consider a circle or a sphere, okay, which is polished, which is well polished. Then let us cut a surface like this. Let us cut a surface. So what happened now? Now this part is separated. Okay, let me do the same here. So this part we cut and this we got a curved surface or a spherical mirror. One side we will coat with the mercury so that side will become opaque, and this is a transparent side. This is a well polished surface. This side is a well polished surface. This is covered with a mercury or a amalgam. Okay, okay. Now, we know that this curved surface is a part of this circle. Fine. So, when we consider this as a part of a circle, this will be having a center. The center is nothing but a center of a circle from which we took this curved surface. So, this center we can name it as C. Okay. So, by the spherical mirror, in terms of spherical mirror, this center of a sphere from which this spherical surface has been derived is called as center of curvature. So, the first term we are going to learn is a center of curvature. It is nothing but a center of a sphere from which the surface has been detached or derived. It is denoted by letter C. Okay. So, when we consider the center point on the spherical surface, the center point on the spherical surface. So this center, it is called as P. or we can say the pole of a spherical mirror. It is called a pole of a spherical mirror. So here also we will do the same. This is the pole we can consider. This is a spherical surface. This is a pole. Okay. Now, when I draw an imaginary line between the pole, don't consider this line. When I draw an imaginary line between the pole and the center of curvature. Okay. So what we will get? We will get an imaginary line which we can call it as radius. So this we learnt in a geometry. A line joining the center of a circle to any point on the surface of a circle, on the circumference of a circle is called radius. So in the spherical mirror also we can tell that the line joining the pole of a spherical mirror and the center of curvature. So this line is termed as, it is denoted by capital R. This line is termed as radius of curvature. Okay, then when we draw an imaginary line, after this when we draw an imaginary line which is passing through the pole and the center of curvature, so this is called as, this imaginary line is called as principal axis. So these are the terms which we are going to learn with the spherical mirrors. Pole, center of a spherical surface, okay. Then C, that is center of curvature. It is the center of a sphere from which the spherical surface has been derived or detached. And R, radius of curvature. The line joining the center of curvature and the pole is radius of curvature. Then principal axis, the imaginary line which is joining or which is passing through the pole and the center of curvature, passing through, it is called as principal axis. Okay, so these are the terms which we have to remember when we are learning regarding the spherical mirrors, principal axis. Okay, then let me write this. Okay, when we consider a spherical surfaces, sometimes a spherical surfaces will be the transparent, that is the well polished surface will be bent outwards and sometimes it is bent inwards. Okay. When the spherical surface of a mirror is bent outwards, outside, then that spherical mirror is considered as a convex mirror. It is considered as convex mirror. Okay. Then when the spherical surface is inside, when the spherical surface or a transparent surface is inside, then it is called as concave mirror. Well polished surface, if it is outside, that is convex. Well polished surface that is inside, that is concave mirror. Okay. So based on the curvature, we have two types of spherical mirrors, convex and the concave. Let us consider. Now, this is a convex mirror. If this is a sphere, okay, this is a sphere. This is a sphere means a circle. Okay. So center of curvature lies here. What we can say, this is a reflecting surface. This side is a reflecting surface. We can say that in the convex mirror, the center of curvature lies behind the reflecting surface. Behind. It is behind the reflecting surface. Hindgade. Okay. Next, when we consider the reflecting surface of a concave mirror, so when we draw just a rough diagram, rough circle over here, center of circle will come here. And this is a reflecting surface. So here the center of curvature is in front in front of the reflecting surface. So in convex mirror, the center of curvature will be behind the reflecting surface. In concave mirror, the center of curvature will be in front of the reflecting surface. So this is regarding certain terms which are important regarding the spherical mirrors. Next. Now, we have to talk about certain activity. What we are going to learn? So, let us consider a concave mirror. Let us take a concave mirror and go to the sunlight. So, let us try to focus the sunlight towards one paper. Okay, towards a paper. So, what happens after few minutes? You can find a light spot on the paper. Then after that, after some time, it starts burn. Then with a smoke. Then after some time, it may also catch the fire. Why all this happened? What happened to the sunlight when we kept a mirror? When we focus that light to the paper, what happened? What is exactly happening? What is that light phenomenon? Okay, this we are going to learn in the upcoming class. Okay, it is a very interesting concept. Today we had learned regarding the terms of spherical mirror, center of curvature, pole of a spherical mirror, radius of curvature and the spherical, principal axis. Then also we learned regarding convex mirror and concave mirror. Let us meet in the upcoming session where we are going to learn regarding the light phenomenon through the spherical mirrors. Until that, have a nice day.